In this video, I'm going to review the Chapter 7 supplemental problems, first using Excel and then by hand using the normal distribution Z table. For question 1, according to the Graduate Management Council, the average starting salary for an MBA graduate in last year's class was $85,854. Now that is your population mean. Assume the population standard deviation for starting MBA salaries was 11,700. You took a random sample of 40 MBA graduates from last year's class. A, what is the probability that the sample mean is more than $81,000? So I'm going to start off answering this question, and I'm going to draw a distribution for you. So here's our distribution. We're going to have the population mean in the center. Create some more space here. So we have the 85,854, and please excuse the bad handwriting. We are then trying to find the probability that the sample mean is more than 81,000. So 81,000 is going to be somewhere over here to the left of the population mean, and that is our X bar. We are trying to find the probability more than. So this is the space where we're trying to find the probability. So with these types of problems, when we're asking about the probability of a mean, the first step, and this is whether you do it by Excel or by hand, your first step is going to be calculate the standard error. And that formula is your standard deviation divided by the square root of your sample size. So equals the standard deviation was 11,700 divided by the square root, SQRT, open up parentheses, our sample size was 40. So this is our standard error. Now we're looking for the probability of everything less than 81,000. So I'm going to put that here. And the fastest way to do this is to use the norm.dist function. So I'm going to put in equals norm.dist, open parentheses. First, I'm going to put in that sample mean that we're trying to find the probability for. So 81,000. Then we're going to put in the population mean, which was 85,854. Then we're going to put in the standard error, which is this number here. You can just click on it so that no rounding is taking place, and then comma true. So that's the probability of everything less than 81,000. If we want the probability of everything more than 81,000, we're going to do equals 1 minus, and just click on that number. So we end with something that rounds to 0.995653. If you were to do this by hand, you would still have to calculate this standard error using this math here. Then you would get the Z-score. So to get our Z, we would do equals, open parentheses. We would take the sample mean, so 81,000 that we're trying to find the probability for, minus the population mean, close parentheses, divide by the standard error, which I'm just going to click on it here. Then we would have to look in the normal distribution table to get the probability of everything to the left of that Z-score. We're going to have to round the Z to negative 2.62. So then I'm going to open up the table. I'm going to find negative 2.62, which would be here. That's going to give us a probability of 0.0044. So then getting the probability of more than, we're going to do equals 1 minus that 0.0044 from the table. Notice how this number and this number, they're very close together. So, whether you do this by hand or in Excel, you're going to end up with the same answer. Okay, so B. What is the probability that the sample mean is between 83,000 and 85,000? So I am going to draw another little distribution. So this one was for A. This one is going to be for B. We still have our population mean of 85,854 in the center. 83,000 is going to be somewhere over here. I'm just going to put 83K. 85,000 is going to be somewhere around here. 85K. And we are trying to find the probability in the center. So we're going to basically go through those same steps that we just went through for A, but we're going to do this twice. Once for 83,000 and once for 85,000. Our standard error is going to remain the same. So I'm just going to highlight this to remind us that's still our standard error. We are going to find the probability of less than 83,000, and we're going to find the probability of less than 85,000. So I'm going to do equals, once again, norm.dist, open parentheses. I'm going to put in 83,000, comma, the population mean, comma, the standard error, which I'm just going to click on, comma, true. I'm then going to do that again here. So equals norm.dist, comma, 85,000, comma, 85,854, comma, the standard error, comma, true. Then to get the probability in the middle, which is what we're looking for, we're going to do equals, click the larger probability, minus the smaller probability, and that's our answer. 0.2607. Now, if we would have done this by hand, you'd still, you'd have to calculate your standard error as we did, and then you're going to calculate two z-scores. So a z for 83,000, you're going to get a z for 85,000, and then you're going to get the probabilities from the table and subtract them. The z-score for 83,000, here is the math for that, divided by our standard error. And then for 85,000, so I'm now going to look up those two z's in the table to get the probabilities. So first I'm going to look up negative 1.54, and then I'm going to look up negative 0.46. So for negative 1.54, we are here, 0.0618, and then negative 0.46, we are over here, so 0.3228. So let's see, this one was 0.0618, this one was 0.3228, and then I'm just going to subtract this minus this. And you would end up with 0.261. So notice this rounds to 0.261. This gave us 0.261. So everyone would end up with something that rounded to 0.261 at the end. Okay, so we're going to move on to the second problem. Number 2, after deducting grants based on need, the average cost to attend the University of Southern California is $37,175. So that would be our mu, our population mean. Suppose the population standard deviation is 7,400. We have a random sample of 60 students, so N is 60. That will be taken from this population. A, what is the value of the standard error? So remember our standard error of the mean. This is our formula for it. So we're taking, and I'm going to do this in Excel. You could use a hand calculator if that's what you'd prefer. We are we're taking here equals 7,400 divided by the square root of 60. So this is our standard error. That would be the answer for A. B, what is the probability that the sample mean will be more than $37,175? So this is an easy one. Draw out your distribution. Our population mean was 37,175. So we're just asking, what is the probability the sample mean will be more than our population mean? So remember, the probability to the right of the mean is 0.50. So that would be our answer for B, 0.50. C, what is the probability that the sample mean will be within 1,000 of the population mean? Okay, so 1,000 above the population mean is 38,175. 1,000 below the population mean is 36,175. We're going to find the probability in the center. So let's open up Excel to do that. So we're looking for the probability of less than 36,175, and then the probability of less than 38,175. So we're going to do, we already have our standard error, so we're going to do norm.dis twice. X would be 36,175, comma, the population mean was 37,175, comma, the standard error, comma, true. And then I'm going to do the same thing again, but with 38,175. Standard error, comma, true. Let me just double check everything that I did. So 36,175, 37,175, standard error and true. Okay, so then we're just going to subtract this one minus this one, the larger one minus the smaller one. So that's going to be our answer, 0.70479. If you did this by hand, you would get the Z for each of those X values. So you would do equals, open parentheses, the 36,175 minus 37,175. Close parentheses, divided by the standard error. And then you would do the 38,175 minus 37,175 divided by the standard error. So those would be your two Z-scores. You would look in the table for a Z-score of negative 1.05 and positive 1.05. So you're going to get 0.1469 right here, and then positive 1.05 would give you 0.8531. So let's just jot those down. These are our probabilities to the left of each of these Z's. And then we're going to subtract larger minus smaller. And notice we got 0.7062. Now, that's a little different from what we got using Excel only, but it's very close. And sometimes that happens because when you're going through the process by hand, you're rounding at multiple steps in the process. The table, those are all rounded figures, so you might end up with an answer that's slightly different, but very close. Okay, then the last question on here, how would the probability change in part C if the sample size were increased to 100? So what I'm going to do, I am going to copy all of this. We're just going to do this one by Excel. I'm going to copy all of this, paste it down here, I'm going to make a note. For this one, our sample size was 60. Now notice in our standard error, that's where we put the sample size. And then with these functions, we had just clicked on the standard error. So down here, we're going to update that standard error formula to a sample size of 100. And now these are going to automatically update. So what happened to our probability? So our probability got larger, right? It went from 0.70 to 0.82. And that concludes Chapter 7, Supplemental Problems. Don't hesitate to reach out to me if you have any further questions.